So this is the Haptics Lab. This is where I spent actually a lot of time during my robotics master's program. So we do a lot of human-machine touch interaction here. Haptics is officially the science of touch. So I worked on a few projects here. This is actually the VeriTouch system. This is what puts touch feedback into the Da Vinci surgical robots. This is, I think, the most exciting project I've worked on here, just because nobody's really been able to do this effectively. Catherine Kuchenbecker, who runs this lab, she actually took this out to Intuitive maybe about a month ago, and we sort of all wondered whether they'd done it before or anything, because the concept is actually not terribly complex, but it turns out that they were really excited by it too. So we're hoping that what happens is that with a sense of touch, you know, that surgeons are more accurate, that it's possible to do these surgeries more quickly, and that's really a big improvement over it's safe now, so you don't have to worry about the robot inside of you. But the issue is that, you know, you can't feel when a needle slips, or you can't feel you know, when the tools collide, and this is really exciting because it allows you to do all these things. So if anybody wants to try this demo, we can turn it on. I actually so another course that you can take in the robotics program is the Engineering Entrepreneurship 1 and 2 courses. This was actually the subject. I used this in my Engineering Entrepreneurship 2 class to formulate a business plan around, and we won best presentation. So it was good. So it's come through a lot of different things within the program, classes and just research work. So I encourage people to come over, give it a shot. We do not have a Da Vinci, as I mentioned. They're quite expensive, but normally this would be mounted onto the master, which is the part that the surgeon controls. There's actually a sensor clip, which we don't have here. It's in the box over there, but that would be mounted onto the arms of the Da Vinci. And then we basically just take the acceleration signal from the arms of Da Vinci. We process that signal, amplify it, and then we put it out to the surgeon's hand. And it allows you to feel a lot of texture and stuff like that. So if you want to just put your fingers in like that, just pinch that. I'll let you do it for yourself in a second. But all of a sudden, all these surfaces that you couldn't feel before, you know, if I go to grab this suture and it's not in there, you know, you can actually, I wish it was stuck in there, but it's not. You could actually feel it slip. But, you know, if I grab this, you know, all these surfaces that you could never feel, all of a sudden the surgeons can, if you want to operate both, you can do that. But it's fine. I can turn it off so you can sort of see what it's like with and without it. But yep, there you go. You are holding this rigidly, so it's you can feel the vibrations just through the virtue of this tool. But the surgeons who aren't attached to the real robot can't really do any of that stuff. So I don't know. If anybody else wants to try it, well, I'm gonna try it. You don't have to try it either. So give it a whirl here.
What kind of actuators are inside this thing? So
these are actually from a company called H2W. They're what's called voice coil actuators. They basically just move that mass back and forth based on this accelerometer here.
It's just that one?
Yep. Actuator. So what's interesting is that your fingers actually aren't sensitive to direction. So it doesn't really matter since we only have one axis here. You can't tell one way or the other. We are actually going to a 3-axis system. Our accelerometer have 3 axes, so you'll get a lot more detail. But yeah, we actually the whole system was actually manufactured here, designed here, so everything was done here. If you want to operate yourself.
That's awesome. And you have a FTM printer that printed these parts?
Yeah, exactly. So we have a Dimension Elite 3D printer. That's another nice thing about the facilities here, is that, you know, you can do a lot of rapid prototyping. We have a machine shop as well, and I've machined all the case and all the rest of that in there. But you know, you can do a lot of different things, which is fun.
Wow. That's pretty cool.
So if you want to So that's sort of weird. You're like your own little closed loop system there. But so softer tissues, so it doesn't do force feedback. So if you were to push, you wouldn't get a push back. But we're hoping to find that having a lot of tactile information really helps you understand event cues. So if you make a collision, or you hit something on the side that while you're doing a surgery, that those will sort of tell you, okay, don't smash into that so hard.
That's really cool.
Yeah. So anyway, but
Great shot. Thanks.
yeah. Sorry, I hope I'm not holding anything up here.
What do I do?
Oh, it's just put your fingers in like that. So you're feeling all these different surfaces just based on the accelerometer that's up here, and we're just taking that signal. Something like that.
So is it like an exaggerated feeling?
So it's amplified, and actually I have the gain set down fairly low here, but you can, it tends to feel better at lower gains. It's more realistic, just based on the saturation of that actuator. But you can probably, can you feel the edge of, you should be able to even feel the edge of that sticker. I mean, it's fairly high resolution. So yeah, if you want to even operate it yourself, sure.
So I work at Johns Hopkins, right?
Oh, all right.
And one of the...
You work with Allison?
No.
Okay.
But I know a few people who work in a lab, and they were saying that they were really frustrated with one of the surgeons because she came in, she had never done this before, and she was smashing them together like nothing else, and they were all scratched up. But I think it would have helped quite a bit if she...
Yeah, absolutely. So that's one of the funny things, is that you sort of realize, how hard you're pushing. And there was an interesting article that came out, I think it may have even been in the Wall Street Journal a few weeks ago, that was just about that there were a lot of times these accidents because people just didn't realize that, they were making collisions in bladders. They were debating whether it was the fault of the surgeon or what was... It was unclear exactly what was going on, but the idea, I think, is that if you have an extra sense, if you have your sense of touch, it's really important that, yeah, please, go ahead. So that you're much less likely to sort of make these errors.
Yeah, that's okay.
Well, hopefully our user study will show that, otherwise. So that's a softer surface that you probably won't feel quite as much on.
What are the normal controls for a surgeon mounted on?
So usually they have, there's actually, I have a video on that computer, but generally they're just holding what are called these master handles. And actually, if you look over my desk over there, you can see the newspaper sort of shows a typical setup. But there's a surgeon sitting in a booth, and he has these grippers that are sort of similar to that, and that's sort of why I designed those little 3D printed parts. But they hold it like this, and they basically just manipulate. It's almost it's like a zero gravity environment there, because they compensate with the motors the weight of the mass of the actual master handles, and they just manipulate the robot
and the handles
inside.
Move all around without being attached in a swivel or anything.
Yeah, so they're attached in the back. They have servos, and they have motors that sort of support them up. But they basically, the surgeon's motions are processed, scaled down, and translated to the instrument that the robot physically uses. Maybe if I hold it down, it's usually a little bit more effective.
Applications other than medicine? Like,
Yes.
I know gaming, like I've never used it myself, and I don't know too much engineering, but there's like a Falcon something.
Yeah, Novin Falcon. Yeah. It's interesting because Joe, who works in the corner over there, I don't know if his demo's up, but he has a texture pad demo where he's basically created these algorithms that predict what surfaces feel like, and you can actually run the pen that's over there over these surfaces. So, yeah, exactly. So, for example, Catherine has ideas of, you want to shop for jeans online. You want to know what the feeling of that the texture of that material is. You want to feel that material. So an idea is that you have this you feel the surface, or you feel the texture of something. You know, these corduroys have the right frequency of the material. So sort of all these, there's a bunch of different applications of this, what's called high frequency acceleration signaling. But it's really, it's a fairly simple concept. I always describe it as you have two cups and a string in between it. I mean, you're just really just sending that signal around, which is why it was interesting that Intuitive, this company that makes the Da Vinci, hadn't tried to implement this. So, all right, cool. Well, thanks trying it out. We'll go this way. I wonder if Joe's texture pad is up. So just quickly, it's not on, but you can see this is Joe's texture pad idea. And what is, you have generally there would be surfaces here, and you could feel these surfaces with this pen, and it would just replicate the frequencies that you would normally feel on the material. So here Joe has like a real, this is denim, and then he has like a fake denim over here that you would feel. So there's a lot of potentially interesting applications, but it's fun. So sorry, we'll go to the other labs here. What's up, Brinza? Show us your stuff, man. It's broken.
Fixing it up.
So this is the grasp lab. A lot of the PhD students are in here in these cubicles, but a lot of things like RoboCup. Dinesh is also a master's student. Jordan, what are you? Are you a master's student? Undergrad. He's just really smart. But a lot of the practice for RoboCup happens here. DSauce, what do you got going on right here? How's Darwin treating you?
Still a lot of fixing.
Still a lot of fixing.
Yeah.
So anyway, but a lot of the research. This is like the main grasp lab, and then there's parts like haptics is part of the grasp lab, and the mod lab is part of the modular robotics is part of the grasp lab, the plan lab as well. So as I sort of mentioned in the talk, there's all these different things that you're interested in doing within robotics. You have those opportunities. RoboCup is always pretty fun, but sometimes these robots can be frustrating. So I'm trying to think what else is interesting in here. Pretty much it. So this is like the main hub, though, and everything else is kind of an offshoot from here. So Segway is a Segway robot over there, which what's that? Yeah, 3D mapping. So I put a hole in the side of it today so we could get a computer cord in there. But yeah, so this is the main hub, and not too much else going on. Come on, Jordan, make a kick. Yeah, all right. We get that on video? Good. Yeah. It's like Jiggly Baby crawling to adult. So this really combines, though, a lot of different important disciplines within robotics, such as ball circling, but vision and planning. What else? Pretty big in vision, right, Dee?
Yeah, localizing, planning.
Yeah, Dinesh was my partner in mechatronics Robaki, and the robots were okay. They were pretty good, but all right. Very cool. He'll get there. He's learning. So anyway, all right, man. Thanks. So yeah, that's about it, guys. So I'm trying to think. Is there anything, Mike? Is there anywhere else we should check out?
Well, we're going to go down to the Precise Center.
Precise Center.
Yeah,
Okay.
that's the embedded systems.
Oh, okay. Cool. All right. Yeah, let's do
You
that.
want to come down?
Yeah, sure. I'll come check it out. I'd never been in the SIG lab either.